So welcome back guys. Hope you are doing absolutely fine. Now in this assignment we will be doing support vector machine. I hope you have watched the previous video explaining about the concept and theory of support vector machines. If you haven't checked it out yet, then do check that out. I'll share the link in the description or somewhere on the screen. So now let's start with the overview of the problem given here. It says, as a business analyst at a large automobile manufacturing company, we are tasked with building a predictive model that will help the engineering team classify the miles per gallon of theoretical designs of concept cars that they are working on. So again, for this assignment, we'll be using the auto dataset. So let's see what question 1 is saying. It says, read in the data and make a scatter plot and state the observations. So we can read the data and store it in the variable svm underscore data. Then we can check the structure of the data. So here you can see the structure of the data is displayed. However, as we have already used this data, so I will not go on explaining the structure or summary of the data. So let's straight away move to the next step, which says check for NA values. So we can check the NA values. It is coming out to be 0. After this, we'll make a scatter plot. Now we will use the plot function and give our data as the argument, but we will exclude column number 7 and column number 8 because these are two categorical variables, MPG and origin. We will run this and our scatter plot is printed as shown here. Now again, the same rules of interpretation for a scatter plot will be applied here that we had discussed in the first assignment, discriminant analysis. So I'll not explain those rules again. Then you can go to the assignment video of discriminant analysis and learn them. However, there is an explanation that I have included here, which I have arrived by implementing those rules. So let's read the explanation now. First point says, variable cylinder is uniformly related with all other variables. So you can see that variable cylinder is uniformly related with all the other variables. Then displacement has a positive linear relationship with HP and weight, and a negative linear relationship with acceleration, and with ears it is more of a uniform distribution. So you can check the scatter plot above and see for yourself all these points that I have listed here. But just to save time, I am going to read this out and move on. Now the third point says, HP and weight are linearly related in the positive direction, and HP and acceleration are related in a linear negative direction. And with ears, it is a uniform distribution. Fourth point says, acceleration and ear are uniformly related. So now let's move on to the next question. It says, create a support vector machine model with a linear kernel. Then try different values for the cost parameter and use the predict function and compare the predictions with the known values. So first we will load the library that has the SVM function. So it is the E1071 library. After that we can build our model using the SVM function. So our dependent variable is MPG here. It will be followed by a tilde and a dot, and then next argument is our data, which is stored in svm underscore data. Then type is classification, and in the kernel we'll mention linear. We will run this and store it in the variable svm underscore linear. After this we can check the summary of our model using the summary function. And here you can see the output of the summary is printed here. Now I have given an explanation here. So let's read the explanation to understand our model. So if you see the output of the summary, under the call, we have the formula of SVM written. Then the parameters are listed. So we have given a classification, the kernel is linear, and here cost is showing 1. So if you read the first point of explanation, it says cost is equal to 1 results in a model with 88 support vectors. So if you see the summary, you can see there are 88 support vectors. Now the second point says the SVM model has a cost function which controls training errors and the margins. For example, a small cost creates a large margin, that is a soft margin, which has a low accuracy and allows more misclassification, and vice versa. Then the third point says gamma is a parameter used in the Gaussian kernel. You can check this using the $sign. Now when you use RBF kernel to raise the data in higher dimension, gamma controls the shape of the peak. Small gamma will result in a pointed bump and a large gamma will result in soft bump. In other words, a small gamma will give you low bias and high variance, while a large gamma will give you a higher bias and lower variance. Fourth point says we can also tune the model with different values of cost. For this purpose, we can use grid search. Now what is grid search? Grid search is the process of performing hyperparameter tuning in order to determine the optimal values for a given model. This is significant as the performance of the entire model is based on the hyperparameter values specified. In this scenario, you have several models, each with a different combination of hyperparameters. Each of these combinations of parameters, which correspond to a single model, can be set to lie on a point of a grid. So for example, we have 4 different values of gamma and C in support vector machine. So grid search will train a support vector machine on all these 4 values, and then it will use CV, which is cross validation, to select the best model. Now you might be wondering what is the difference between a parameter and hyperparameter. So a model parameter is a configuration variable that is internal to the model and whose value can be estimated from the given data such as weights, coefficients, split points and decision tree, etc. On the other hand, a model hyperparameter is a configuration that is external to the model and whose value cannot be estimated from the data. So this is external to model and cannot be estimated from data. Instead, we supply it. For example, learning rate, cost kernels, depth of decision tree that we saw when we did assignment on decision tree, etc. All these parameters are called hyperparameters. So we use hyperparameter to optimize the model. So when we say we can tweak the parameters of the model to get better results, it means that we are talking about hyperparameter. Because as I said, hyperparameters are external to the model. So it is up to us to control them and tweak them to get better results. Now we will see how do we tune the model. So we will use the tune function here. So tune function take method as the first argument. It is a generic function for optimizing hyperparameters using grid search. So we can use this function with different methods. Here we are using it with support vector machine. Then the second argument will be the formula. Then we will give the range of our cost values. So we will generate sequence starting from 2 till 100, each incrementing by 10. Then we will just run this and store it in the variable tune_linear. After this, we can check the summary of our model. Now summary gives us different cost values, error and dispersion. Here dispersion is nothing but standard deviation. Now if you look at the summary, it is saying that the best cost is 72. We can also see in the table that error value is minimum against the cost value of 72. Now we'll move to the next question, which says create a plot to select the best model. So we can again use the plot function. The first argument will be our tuned model, which is stored in the variable tune_linear. Then we will mention the main title as MC versus cost. We will run this and we can see our plot is printed here. So we will refer to the explanation. It says basically we will select the model that has lowest error. Now from the plot we can see that error is lowest at around c is equal to 70. And hence the best model is given at cost is equal to 70. So either you can use the plot here, or you can simply go by the output of the summary, which says c is equal to 72 is the best cost. So that is how we tune the model. So we can tune different parameters to improve the results. Now we'll move to the next question that says predict the data using the best model. So for prediction, we will first extract our best model using the $sign as shown here. So our tuned model is stored in tune_linear. We will put a $sign and then mention best.model. We will store it in the variable svm_linear. After this, we will make the prediction using the predict function. So the first argument will be the model. So we will use our best model. And the second argument will be our data. We will run this and store it in the variable predict_linear. Then we can check the misclassification error. So we will build a confusion matrix using the table function. So the first argument is a dependent variable. Then the second argument is the predicted results. We will run this and store it in the variable cf_linear. After this, we can check the misclassification error by taking the sum of diagonal elements and dividing it by the sum of all the elements. Then we can subtract it from 1 and multiply it by 100 to get the results in percentage. Now as you can see, we are getting results of 3.06%, which means our misclassification error is only 3%, which is a very good result. But again, there is nothing to be happy about it. If you refer to the second point of the explanation, it says, as we have not done train test holdout and made our prediction using the trained data, hence error is low. So there is nothing great about it. However, you can split the data into train and test and you can repeat the process. My intent here was just to show you the process. So that is how you perform support vector machine. Now we'll move to question 4. It says create a support vector machine model with a radial kernel. Then try different parameters for the degree and gamma parameters. Use the predict function and compare the prediction with the known values. So again, we can use the svm function as we did above. The only change here is we will mention kernel is equal to radial. Then we can run this and store it in the variable svm_radial. After this, we can again check the summary. Now you can see the summary is printed here. Now if you see the explanation here, it says cost is equal to 1 and gamma is equal to 0.143, results in a model with 102 support vectors. Now the gamma values are not given in the summary. If you want, you can use the $sign and check the gamma values. I have already checked it and hence I have mentioned gamma is equal to 0.143. After this, we will tune the model. So in tuning, everything remains the same. We will only add the sequence of gamma in the range argument. So here we are varying gamma from 0.1 to 0.4 by an increment of 0.5. And then we will run this and store it in the variable tune_radial. Now one thing you should note that if you are varying two hyperparameters and for one parameter, let's say there are 10 increments, then for second parameter also you should mention 10 increments. Otherwise you will get an error. For example, if you see here, there are 10 increments for our cost parameter. Similarly for gamma parameter as well, I have mentioned 10 increments. And then we can check the summary of our model. Now if you see the summary output, it gives us the cost, gamma values, error and dispersion, which is basically standard deviation. It also says the value of best parameter is cost is equal to 22, gamma is equal to 0.6. Now that we have tuned our model, we can move on to the next step, which is to make the prediction. So again, first we will store our best model using the $sign and store it in the variable svm_radial. Then we will make the prediction using the predict function. The first argument is the model and the second argument will be our data. We can run this and store it in the variable predict_radial. After this, we'll find the misclassification error. So we will use the table function as we did above and store it in the variable cf_radial. We can also print our confusion matrix as shown here. And then we can find the misclassification error as shown here. And here you can see the misclassification is coming out to be 1.02%. Again, nothing great about the results because we have trained our model on the same data and then tested it on the same data. Now let's move on to the next question, which says create a support vector machine with a polynomial kernel. Try different parameters for the degree parameter, use predict function and compare the prediction with the known values. Now again, everything remains the same in the SVM formula except that we mention kernel is equal to polynomial. And then we will store it in the variable svm_poly. Then we can check the summary of our model. Here if you see, the parameters listed are SVM type, which is classification, kernel, which is polynomial, cost we have 1, degree of polynomial is 3, and so on. Now we can see the number of support vectors are 151 here. Now let's straight away jump into tuning the model. Again, everything remains the same. We have just added one more hyperparameter here, that is the degree. Also, I have reduced the range of these parameters as it was taking too long to run this code. Then after running it, I have stored it in the variable tune_poly. Then again we can check the summary. Now in the table along with the other 3 parameters, we can see that degree is also printed. And as far as the best parameter is concerned, it says degree is 2, cost is 2 and gamma is 0.6. After this we'll make the prediction. So first we will store the best model. So we are storing it in the variable svm_poly. Then we'll make the prediction using the predict command. And then we'll find the misclassification error by creating the confusion matrix as shown here. So if you see, the misclassification error is coming out to be 3.82%. So that is how we build the SVM model using different kernels, then tune it and make the prediction. Now let's move to question 6. It says, from the above created few different support vector machine models, which one do you like the best and why? Also, what features of the data lead to your choice of favorite model? Now the answer given here is, the error rate is more or less the same for all 3 models. However, we know that there are different parameters that can be varied to tune these different models. We can also carry out train and test holdout, and then we can check the performance of our model. However, at this point, we cannot conclude which model is better. And the whole idea of this exercise was intended to demonstrate the procedure and understand the output of the model. We were not trying to build the best model anyways. Now the second point says, still we can devise a criteria for choosing the best model as follows. Point A says, lowest misclassification error. So in our case, it is given by linear kernel model. Second point says n, which is the number of observation, that is 392, is large as compared to number of predictors m, which is equal to 8. Hence, support vector machine with linear kernel in this case would be the preferred choice. Now there is a small exercise given here at the end. It says try to split the model into train and test data and perform the assignment, and then report what difference do you notice. So with this, we will wrap up this assignment. In this video, we have learned the implementation of 3 different support vector machine models, that is with linear, radial and polynomial kernels. We've also seen how we can vary the hyperparameters to tune the models and improve it. I must say, implementation of support vector machine so far was easy. So if you understand the theory, you can easily implement it. Still, if you have any doubts, then do watch the video where I've gone through the theory concept that will help you understand the topic better. Now I'll catch you guys in the next video where we'll be discussing another topic of advanced modeling. Until next time, see you and take care.